Okay, so what we were talking last time, limit of sequence. So algebra of limit of sequences, right? So can you see the screen?
Yes, sir.
Okay, so we proved that limit of xn plus yn is limit of xn plus limit of yn, right? Correct? And then similarly for subtraction, right? Did you work it out for minus subtraction of xn and yn? Yes. So if xn converges to x, alpha is real number, then alpha times xn converges to alpha times x. Okay, so given epsilon, we want to produce k such that this is less than epsilon for all n greater equal k. So this we want, right? Now to prove this, how to what should be the strategy so that we can given epsilon we can produce k. So what should be the strategy? So what is the strategy? Do you understand how to prove this? Yes. If you want to make alpha times xn minus alpha x less than epsilon, that means what? See, this step is important. See, from that how to make, so given epsilon, how to produce k, so that this difference would be less. So epsilon is given. Now you want to produce k. So what is k? And here in yellow color, see, I have written something. So if you want to make this less than epsilon, right? So if you want to make this less than epsilon, alpha times xn minus x, if you want to make this less than epsilon, that means what? The xn minus x, this distance we should make less than epsilon, right? So what is the strategy? Given epsilon is given, what we want k, so how to get k, right? Can you hear me?
Yes, sir.
Sir.
Ah, so what we want, is it clear? We want to make alpha times xn minus alpha x less than epsilon. But
Yes, sir.
from this previous calculation in yellow color, this we get some idea. So suppose alpha is non-zero. If alpha is zero, then nothing to prove because each alpha times xn is zero, it converges to zero. So not an issue. So if alpha is non-zero, then what? Since limit xn if limit xn is equal to x, right? For epsilon 1 is equal to this number. So is it positive number? Is this positive number?
Yes,
Why? What is
because
the huh?
Because the absolute value of alpha will be positive.
So absolute value of alpha is positive, it is non-zero, and epsilon is positive is already given, and for that epsilon we are willing to find k, right? So we are looking at this number since limit of xn is x, for any epsilon we can produce k. So in particular for this epsilon there exists some k, right? Such that xn minus x is less than epsilon 1, which is epsilon upon alpha, right? Therefore, if n is greater equal k, then if n is greater equal k, can you make alpha times xn minus alpha x less than epsilon? Let us check alpha times xn minus alpha x, right? This is alpha xn minus x. But what is next step? What should I write here? This amount is less than what? Can I say that as alpha as it is? Can I say that this amount is less than epsilon upon alpha? Is it true?
Yes, sir.
Yes, sir.
Why? Because n is greater equal k, and if n is greater equal k, xn minus x is less than epsilon upon absolute value of alpha, right? And therefore this is epsilon. Therefore what we get, therefore alpha times xn minus alpha x is less than epsilon for all n greater equal this k. Thus what we have proved, hence given epsilon we can produce k such that what, alpha times xn minus alpha x is less than epsilon for all n greater equal k. Right, so what is the conclusion? What is the conclusion? Right? So conclusion is,
Limit of alpha xn is equal to alpha into limit of x.
right, therefore limit as n tends to infinity alpha times xn is alpha times x. Right, because for any epsilon we are able to produce k and declare that limit is this number, right? Okay, next. What is our next claim? What is our next claim? Limit n tends to infinity xn into yn is xy. That means limit of xn into limit of yn. Right. This we want to prove. Correct? Is it clear?
Yes, sir.
Yes,
Yes,
sir.
sir.
How to start the process? How to initiate the process? That is what we want.
For any
What,
alpha greater than 0.
that is we want to prove that given epsilon there exists k such that, right, we want given epsilon there exists k such that xn yn minus xy is less than epsilon for all n greater equal k. This is our aim, right? If we want to produce k for every epsilon, then we can declare that key limit is xy, limit of sequence xn into yn is xy, right? So how to start? So given epsilon, so the process starts with epsilon. What we want k. Is it clear? Idea is clear,
Yes, sir.
right? But what type of k we want? K, that means every n greater equal k, this difference should be less than epsilon. This is our aim. So let us try to simplify this difference so that we can easily guess what is the value of k, right? Consider this. So first of all, I will try to simplify this difference so that I can easily guess what should be the choice for k. So xn yn minus xn y plus xn. So I will just add and subtract xn into y. Correct? Which n I am adding? Which xn I am adding? Is xn, which xn and into y? Which xn I am considering in this case? Right, xn yn. Xn yn means I am just talking about some term, and so that I want to simplify this difference. So that corresponding n xn into y. I am looking at corresponding xn into. So, okay, so let us simplify this. Please keep your mic off, Sania. Okay, so what next? What I can do further according to our
Triangle inequality.
Equality.
right? So absolute value of xn into absolute value of yn minus y plus absolute value of xn minus x into absolute values. Is it clear? Is it correct what I have written?
Yes, sir.
Yes, sir.
Right. So this is what we can simplify difference xn yn minus xy. Let us call this as expression 1. But somehow, if I am able to do something, right? If somehow I am able to make this xn less equal m for some number m, right? Then what I will get? What I will get? Xn into yn minus y is less equal m times yn minus y. Right, this is in my mind. So can I make this thing less than this number? Right. Or if
Yes, sir.
somehow I can make this first thing less than epsilon by 2 and this second term less than epsilon by 2, then I will be able to make this less than epsilon. This is what is going on in my mind. Right. You understand?
Yes, sir.
Yes, sir.
Now, can I make first term less than epsilon by 2?
Yes, sir. By making yn minus y equal to epsilon by 2m.
Very good, right. So if you make yn minus y less than epsilon upon 2 m, then ultimately this thing would be less than epsilon by 2. Same thing for, okay, so now I can get some idea how to proceed. So what should be my next statement? Since, but how to make xn less than m? Why?
Xn is
Sir,
a
xn should
convergent
be bounded.
sequence.
Xn is convergent and hence bounded. Because we have already proved that convergent sequence is bounded. So xn is convergent, therefore it is bounded. Therefore there exists some number m such that the absolute value of xn is less equal m for each n. Right? Therefore, further, since limit of yn is y for epsilon 1 is equal to epsilon upon 2m. Is this positive number? Does this make sense?
Yes, sir.
Yes, sir.
Right, because epsilon is already given. So we know epsilon and we found m in this previous stage. And so look at number epsilon upon 2m, which is certainly positive number. And since limit of yn is y, so for any epsilon we can produce k. In particular, this epsilon also there is some k. Correct? Right, so since limit of yn is y, for this particular epsilon, there is a k. Let us call it as k1. Right? Do you agree? There is k1, some number,
Yes,
Yes,
sir.
sir.
such that the distance between yn and y is less than epsilon upon 2m for all n greater equal k1. Okay, so let us call this as expression 2. Okay, what should be my next? Because now in this way I am able to, I can make first term less than epsilon by 2. How to make second term in expression 1 less than epsilon by 2? Here. How to make this less than epsilon by 2? Do you understand? How to make second term less than epsilon by 2? Yes. I want to make xn minus x less into absolute value of y less than epsilon by 2 means what? Xn minus x less than epsilon upon 2 absolute value of y. Correct? See, what is second term? Right. Our aim is to make this less than epsilon by 2. That means xn minus x less than epsilon upon 2 into absolute value. Is it clear?
Yes, sir.
Yes,
Now,
sir.
is it possible to make this difference xn minus x less than epsilon upon 2 absolute value of y? Is it possible?
Yes, sir.
Yes, it is possible provided y is non-zero. Because we have not, we didn't put any condition on y because y is just limit of y, and so it might be 0. So if y it is 0, then this make a problem, right? So how to overcome this problem? Do you understand? What is the problem?
Sir, if y would be 0, then the second term would definitely be 0. So it would be less than any positive number.
That you can say y is 0, then second term will be 0, right? But if you want to assume non, if you assume y is non-zero, since limit of xn is x for epsilon 2 is equal to epsilon upon 2 into, I will make some smart trick. I will consider this absolute value of y plus 1. Is it positive quantity?
Yes, sir.
Yes, sir.
And then if y is 0, then also no problem. This is well defined number, right?
Yes, sir.
Yes, sir.
There exists k2. So there number k2 may not be same as k1 such that xn minus x is less than epsilon upon 2 times, right? Correct?
Yes, sir.
For all n greater equal k2. Now, certainly this quantity is less than epsilon, then this amount would be less than the second term in our expression 1 is less than epsilon by 2. That we'll see later on. But the idea is clear.
Yes, sir.
Okay, now what is k? So that this expression will be less than epsilon. What is k?
A is maximum of K1 and K2.
Right, very good. Because after, if you choose maximum of k1 and k2, then both things happens, right? Second and third. Let us call it as third expression. So let k is equal to maximum of k1 and k2. Then for n greater equal k, let us see what happens. Xn yn minus xy is xny minus uh, plus xny minus xy. Add and subtract, just we did in the previous. So this is less than or equal to xn into yn minus y plus xn minus x into absolute value of y. But we know that xn is convergent, so it is bounded. So there is number m such that all xn are less equal m. So ultimately this is less equal yn minus y plus xn minus x absolute value of y, right? Now, what next? What next? Can I say that m as it is? Can I say that this yn minus y is less than epsilon upon 2m? Can I say this?
Yes, sir.
Why?
Yes, sir.
Why? Why it is less than epsilon upon 2m?
Because we have selected a case such that
Ah.
is less than epsilon upon.
So we are selecting n greater equal k, and ultimately k is greater equal k1 as well as k2. And if n is greater equal k1, yn minus y is less than epsilon upon 2. Right? If n is greater equal k1, yn minus y distance is less than epsilon upon 2m. That is clear. Further, can I say that xn minus x is less than epsilon upon 2 into, right? Is it true?
Yes, sir.
Because n is greater equal k2 and xn minus x is less than epsilon upon 2 times absolute value of y plus 1. So this is easy to see. So m cancels, so which is epsilon by 2 plus, what is here, epsilon by 2 into y upon 1 plus absolute value of y. Right, but epsilon by 2 plus, can I say that this term is less than epsilon by 2? Yes.
Yes, sir.
Because absolute value of y, right, absolute value of y upon absolute value of y plus 1 is less than 1, and therefore this quantity I am replacing this bracket by 1, so this is less, so therefore this is equal to epsilon. So what is the conclusion? Therefore xn yn minus xy, so we started with this expression xn yn minus xy, and we can at the end we reach to the conclusion that this difference is less than epsilon for all n greater equal this particular k. Thus, for each epsilon, we are able to produce k such that, right, for given any epsilon, we are able to produce k such that this difference is less than epsilon for each n greater equal k. So, what conclusion we can make from this? Therefore, limit as n tends to infinity, xn minus xn yn is xy. Okay, so this proof is clear?
Yes, sir.
No doubt, right? We are just following the definition of limit. So given epsilon, how to produce k, that is the main idea.
Sir,
Yes.
can you just show the first proof like alpha x and
Yes. Yes. This one?
yes, can you go to case go a bit?
Yes.
Okay, sir.
Done?
Yes, sir.
Okay. Now, what is our next point? So limit n tends to infinity xn yn is xy. So this we proved. Now, what about quotient? Yn is non-zero for all n and limit of yn is non-zero, then limit of xn upon yn is limit of x upon limit of xn upon limit of y. Correct? So what is next? What is claim? if yn is not equal to 0 for all n and limit of yn is y is also non-zero, then what is our claim? This is our claim, right? So first we prove that limit of is 1 upon y. First we prove that limit of 1 upon yn is 1 by y, and then we can use the previous proof, the product of, right? So what is the previous proof? Can we use previous proof after this? Xn upon yn is xn into 1 upon y, and if you are successful to prove that 1 upon yn goes to 1 by y and already xn goes to x, so where product would go? Where product would go? So where product would go?
Limit of xn into 1 by yn is equal to x by y.
Right, and therefore ultimately what is sufficient to prove? 1 upon yn goes to 1 by y. Right, then the rest of the job is easy because we have we can use the previous result. Correct?
Yes, sir.
So therefore what is the crucial way point to prove this? Okay, so how to prove this? So what is our claim? Limit of 1 upon yn is 1 by y. That is what we want. Given epsilon, there exists k such that what?
Absolute value of 1 by yn minus 1 by y is less than epsilon.
Very good. Okay, so this we want. Right? Okay, so given epsilon. So epsilon is given, now our process begins. Our procedure starts. How to produce k? Want to produce k, right? So now our job starts after epsilon, not before epsilon. Unless we know epsilon, we cannot produce k. So process starts after epsilon. So remember this. So given epsilon, now our job is to produce k. But what type of k we want? K after k, the difference is less than epsilon. Which difference? Right? So try to simplify that difference so that we can easily guess the value of k. 1 upon yn minus 1 by y. So first of all, try to simplify this. Right? So without simplifying, it is very difficult to guess what is the value of k. Right? So how to simplify this? So this is equal to what? This is equal to what? Upon. Is it correct?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, now from this final expression, what we think, what is in our mind, how to proceed, what should be the strategy? So in this green color I am writing this. So if somehow I am able to make this thing less than some quantity m, if I somehow I am successful to make this less than some m, then what will happen? Yn minus y upon this y this quantity would be less than or equal to what? Correct?
Yes, sir.
Now, can I make this m times absolute value of yn minus y, this less than epsilon? Is it possible?
Yes,
Yes,
sir.
sir.
Right, because
Alpha.
so if you want to make this less than epsilon, that means we should make yn minus y less than epsilon upon m. And is it possible to make yn minus y less than epsilon upon m?
Yes,
Yes,
sir.
sir.
Yes, because
Yes,
yn
sir.
is to y. So this is a strategy. This is in my mind. So therefore, now go back. What I thought, if somehow I am able to make this less than m, then I will be able to make this less than epsilon, then I will be able to make this less than epsilon. So this is a way. Now go back. Now go to the first point, how to make this less than some number m, right? Right. The next thing happens if we are able to make this less than epsilon. So how? Right.
Sir, can we make a lower bound for yn?
Yes, but what is that lower bound?
So most probably 0.
But it is in the denominator, though
It
that
doesn't
will,
make sense then, sir.
right? If you pull the denominator 0 to the denominator, that creates a problem.
Sir, what if we write minus m?
Oh, what is minus n? Natural. We are talking about natural numbers. So how can you say minus n? Right? So, okay, I will give you hint. What is a hint? And then you can see the proof. Suppose limit of yn is y. I don't know whether yn is positive or negative. Suppose yn is negative. Y is negative or positive, we don't know. Suppose y is negative, but certainly absolute value of y is positive, whatever is y, and we are assuming that y is non-zero. This is our basic assumption. Correct?
Yes, sir.
Yes, sir.
Now, can I choose some sufficiently smaller epsilon so that in this range, that after some k all terms are in this range? Is it possible to do this?
Sir, absolute value of y by 2.
Yes. Right? Absolute value of y by 2. But do you understand? Can we produce such k? After that k all terms are greater than this number, absolute value of y by 2? Is it possible, first of all?
Yes, sir.
Right. So if it is possible, then think about how to make it possible. Means how to write down it clearly. Since limit of yn is y for epsilon is equal to absolute value of y by 2, there exists k1 such that such that what I should write further.
Absolute value of yn minus y is less than absolute value of y by 2.
Right. So yn minus y is less than absolute value of, this is my epsilon, and this is after k1. Because yn converges to y, so for any epsilon I am able to produce number k. In particular, if epsilon is absolute value of y by 2, no matter, anyway it is positive number, whatever it may be, there is some k, let us call it as k1. So after k1 this is going to happen. So okay, so note this. For any real numbers a and b, absolute value of a minus absolute value of b, its absolute value is less equal absolute value of a minus b. Is it true?
Yes, sir. Reverse triangle inequality.
Right. This we already know. Okay, now can I use this here? Therefore, okay, is it clear? What I have written is clear, correct?
Yes, sir.
K1. Fine. Therefore, so this absolute value is less than for all n greater equal K1. Fine. Now I will simplify this further. For each n greater equal K1. What next? What simplification is possible further? What simplifications are possible?
Multiplying two
We can add
sides.
y mod of y.
Right. What we can do further? Absolute value of y minus absolute value of y by 2 for each n greater equal k1. Okay, what next? What next? Correct?
Yes, sir.
Right. And therefore, what is the final here we got? Ki this is absolute value of y, and we found that ki there is k. Ki after k, all terms are greater than this. So we found this number. Correct? Okay, what next? Therefore, for n greater equal k1, 1 upon y minus 1 by y, which is yn minus y upon what? Right? And from this, I should add one more step here. So from this, okay, here after k1 all yns are greater equal y by 2. So therefore, for n greater equal k1, y by 2 is less than absolute value of yn. What does it mean?
1 by absolute value of yn would be less than mod of
Yes.
y by 2.
2 upon absolute value of y. Correct?
Yes, sir.
Right. So okay, then Now I am choosing n greater equal k1. So what? Can I say that this is less than? This is less than what?
Divided by 2.
2 upon y square.
Yes, sir.
Correct? Okay. Now from this, what we observe is if you want to make 1 upon yn minus 1 upon y less than epsilon, what we should do? Yn minus y into 2 upon absolute value of y square less than epsilon. We want to make this less than epsilon so that our aim would be achieved. So, okay, but this is possible if we can make yn minus y is less than what?
Epsilon
Mod of y
into
square epsilon upon 2.
Right. And is it possible?
Yes, sir.
Yes, sir.
Right. So this would be achieved if we can make this less than this number. Okay. So what is next step? Since next limit of yn is y, so for epsilon 1 is equal to this particular number, right? So this number is well defined, correct? Because epsilon is known, y is known, which is limit of yn. So for this positive number, what happens? What happens for this number?
Distance of yn from y is less than epsilon 1.
For what n? Which n? Or every n?
Greater
No, sir,
than
for k2.
So there exists k2. After k2, this is going to happen, right? So there exists k2 such that distance between yn and y is less than this epsilon 1. And for all n greater equal k2. Now what was our ultimate aim? Just go to the first step. What was our aim? Epsilon is given and we wanted to make 1 upon yn minus 1 by y less than epsilon. This was our aim. So what is k for that?
maximum of k1 and k2.
Maximum of k1 and k2. So let maximum of k1 and k2. Then check that this is a required k. That means this k fulfills our requirement. So if n greater equal k, see n is greater equal k and k is maximum of k1 and k2. So ultimately n is greater equal k1 as well as k2. Right? So 1 upon yn minus 1 by y. What is this? Yn minus y divided by, this is by straightforward calculations, but our n is greater equal k1, so this quantity is less than or equal to what? See this step. Since n is greater equal k1, this quantity is less than or equal to this quantity is less than what?
Y square epsilon by
2 upon y square into yn minus y. Further, n is greater equal k, so I will write 2 upon this number as it is, but n is greater equal k2, so yn minus y distance is less than what? Am I right?
Yes, sir.
And this is ultimately epsilon. So what is final conclusion? Therefore, if n is greater equal k, then 1 by yn minus 1 by y is less than epsilon. So therefore, for given any epsilon, we are able to produce k such that no matter what is epsilon, anytime for any such number, we can produce k such that 1 upon yn minus 1 by y is less than epsilon. So what is the conclusion of this? What is the final conclusion? Therefore, right?
Yes, sir.
Now next, what is limit is limit of xn into 1 upon yn, and use the previous result, the product. This is a product of two things, limit n tends to infinity xn into limit of 1 by yn, correct? And so what is it now? Limit of
X
xn is x,
into 1 by y.
so therefore it is x by y. Hence the proof. This completes the proof. Okay, so how this algebra of limit is useful? So let xn is equal to root of n plus 1 minus root n. Find limit of xn. Right. How to find this? Does this limit exist first of all? What is your guess? So if you look at this expression as it is difficult to guess, right? So try to simplify this expression. And how to simplify? Yes.
Position.
See, this expression involves square roots, and so such kind of expression, how to simplify?
Normalization.
So multiply and divide by the conjugate. So what is the expression? What it becomes now? So what is it? Is it correct?
Yes,
What is
sir.
numerator
Yes.
is minus y into x plus y. It is x square minus y square. So this is what we use in the numerator, and therefore what is it? Therefore it becomes 1 upon 1 upon what? Root of n plus 1 plus square root of n, and therefore what is limit n tends to infinity xn, but xn we have simplified in this form. So what is it?
0.
0. So if you want to further simplify this, you can, but anyway, this limit is 0 because denominator tends to infinity, right? Or before that you try to prove that limit n tends to infinity 1 upon root n is 0, then limit n tends to infinity 1 upon n plus n square is 0. So all these are equivalent. Anyway, so this limit comes out to be 0. Right. So what we use here basically is simplify the terms. Okay, now look at this sequence. Xn is equal to 2n square plus 5n plus 7 divided by 3n square plus 6n plus 9. Right. Now what is limit of this sequence? Right. So let us use the previous theorem and first simplify this expression and then use the algebra of limits. Right. So I will take n square common from the numerator, and what I should write in the bracket. Correct.
Yes, sir.
In the denominator, again I will take n outside. You check whether I am writing correctly. So
Yes, sir.
okay, so n square get cancelled. So 2 plus 5 by n plus 7 by n square whole divided by 3 plus 6 by n plus 9 by n square. Now let us calculate limit now. We have simplified the expression. So limit n tends to infinity xn. So limit n tends to infinity. But xn we have simplified in this form. So 2 plus 5 by n plus 7 by n square. 3 plus 6 by n plus 9 by n square. Now use algebra of limits. So how? Limit of quotient is
Limit of numerator upon limit of denominator.
divided by okay, next again now numerator itself is a limit of sum of three sequences, right? So what is it?
2 by 3.
Right, so limit of 2 plus limit of 5 by n plus limit of 7 by n square, because limit of sum is sum of limits. In the denominator same thing, limit of 3 plus limit of 6 by 9 plus limit of 9 by n square. And then what is this limit? So limit of constant sequence is itself. So 2 limit of 5 by n is 0, limit of 9 by n square is 0, divided by limit of 3 is 3, limit of 6 by n is 0, limit of 9 by n square is 0. So ultimately limit is 2 by 3. Right, so in this sense, this algebra of limits is useful, right? So I'll give you some exercises, you just work it out. Find limits of following sequences. Uh, root n so root n into root n plus 1 minus root n, right? Here n cube. Okay, you try to calculate limits of this. So next time we'll see the more about sequences. Right, so any doubt, any difficulty?
No, sir.